So here we go. And we're on the last topic, application development. And last time we started, and I recorded that video here, we started developing a program that plays Connect 4. Just to remind everybody, this is how to play Connect 4. You pick a column. So our user will enter in a column number 1 through 7. This is column 3. And the computer plays column 4. Now internally, this will be column 2, because internally our counting starts at 0. And here it is, we have this data structure called grid. It's a two-dimensional array of char. And there's 6 rows and 7 columns. You can see here, there are 6 rows. And the grid stores char. So inside this grid, we're going to have X for the player, the user, O for the computer, and dot for an open space, we'll say, an open cell. So we have 3 characters that will occupy this grid. You can do the same thing with the tic-tac-toe problem that you're working on. You have 9 cells in the grid. And it can either be a blank or a dot, either one you can use, or an X or an O like that. So it's a similar underlying data structure for that problem. So here we have a function that simply prints the grid. We iterate through the 6 rows, and for each row, we iterate through the 7 columns. And for each row column pair, there's a grid cell that has a character in it. We simply print the character. We also follow with a space here because we want to space things out visually a little bit. So the print function is a nice bit of logic that's just tucked away in this function. So we don't have to think about it in detail anymore. We just know that it works. And we set that aside and call it when we need it. Now the grid doesn't start initialized the way we like, so we have this function to initialize the grid when the program starts. And initializing the grid is, what we do is put a dot in each open cell. All the cells get a dot. Then we have a function that manages the activity of allowing the user or player to move. Could have called that user move. So we prompt the user to select a column, read in the column selection. Here we subtract 1 to convert user counting to our internal counting, which starts at 0. And now what we want to do is find where in the chosen column, so the user chooses column C. So which row in column C do we put the symbol X? And so we have to start at the bottom. Well, essentially the bottom is row 5. And we look there, is that an open cell? If it is, that's where it goes, because these things fall down. See, so these things fall down like that. So we have to search from the bottom up until we find our first open cell. And that's where we put the marker. And we could have numbered, we started the row numbering from the top. So we had, we have this as row 0 up here. That's row 0, that's row 1, 2, 3, 4, and row 5 is the bottom. We could have done it the other way. We could have made this row 0, 1, 2, 3, 4, and row 5 the top. We could have done it like that as well. So it's just a choice, which one you think is easier. I like doing it the other way, but someone made a suggestion that we do it this way. So let's just see how it goes. So we start at the bottom row in column C. If we find a dot, then we can place the character X there. And then we break because we're done. Otherwise, we need to go to the next row. Now the problem with this logic is we can keep the whole column may be filled up, and we don't handle that case. So that's an invalid move, if the column is filled up. So we need to handle that. Let's see how this runs right now. So we're selecting, say, column 1. Now, one more, I'm going to fill it up. Now I select it again, nothing happens. But what should happen? Well, maybe it's okay for nothing to happen. We could print, invalid move, try again. We could do it like that. But it's easier to see it if the computer is playing. So, we do a move, the computer moves. So if we do an invalid move, we can simply skip the computer move and just prompt the user to select a column again. That way we don't need to print an error message. That's the way I want to do it. So we'll wait on checking validity of moves until a little later. What we can do now is have the computer move. I want to do Control-C to exit. Here's the main. Look how simple main is. We looked at all the code. All the code we looked at, plus this simple little bit of main, gives us the behavior that we already have. That's not bad. Let's get the computer to move. So when we start main, we initialize the grid and we go into this infinite loop. It won't be infinite for long. We'll have a condition in there at some point. Or we'll break from the loop in the body of the loop somewhere. So we print the grid and then we call player move. Well, let's just kind of do the obvious thing. After the player moves, let's let the computer move. Let's have the computer move. Well, the computer move will be just like the player moving. Now, look at this. Instead of, selecting, watch, I'll just do it like this. Look how I can see we just need to use AI here instead of a real human. We need to use our code that maybe uses some randomness. Select a column. So we don't need to prompt the computer to select a column. So we'll comment that out, and let's change the names. Let's change it to column. And so this is where the column is set here. But let's just generate a random value for that. How many columns are there again? 7, right? Okay, so mod 7. So it gives me a number from 0 to 6. Those are the columns, 0 to 6. So we're getting a random column number. And we don't need this, right? So this, that C is direct like that. In fact, we don't need to do this. Just get a random column number, 0 to 6. And then we do the same thing that we did for the player, except instead of placing an X, we'll place an O. Let's see if that works. It doesn't work.
You didn't spell computer correctly.
Yeah. Thanks. Rand was not declared. We got to include that thing, right? What's it called again? C standard library. All right, we'll play in column 1, and computer took column 2. We'll take column 2. Computer took column whatever. See, it's stacking now, isn't it? Look at that. So it is working. Also, if I enter column 8, we just lose that move. So now we have the computer moving, and we're not checking for a win condition. We have to find out, each time one side moves, we want to check to see if that player has the winning move or not. So we need to do that. Plus, we need the problem of controlling for an invalid move. We also need to do that. But look here, there's something before we do that invalid. I think doing the invalid move we can do next. But before we do that, there's a bit of refactoring that we should do. So refactoring is like cleaning your code, reorganizing your code to create more simple code, easier to understand code. In this case, we have lots of duplication. All of this is a duplication. This here is the same as this code right there, except for this one little spot right there where we just changed the character that's getting put into the grid. So we can extract the common code and put it in another function. And let's do it like this. So we don't know, we'll have this, we'll call this thing, what are we going to call it? The marker, so, or the symbol, that's what I used to use, symbol. So the player symbol or the computer symbol. So the symbol will be a char that's passed in to this move function. So we don't need this. Is that right? Yeah, I think that's right. And so we need to pass in the column as well. Right, because for the player, for the user, we get the column number from cin, but for the computer, we get the column number from rand. So that's not common code. That's different code. So that has to be out of this function. This function is just to do what's common to those two other functions. So this is what's common, you know, minus this part right there. But that's easy. We can just pass that value in right here as an argument. So now for the player move, we ask the player to select a column. And we do the same thing right here. And then we just now call move. That's the symbol X. See, that's the first argument. And the column number. The same thing for the computer move function. Except the symbol is an O. You see these? Now we've taken out the common code and simplified these functions quite a bit. Oops. There we go. Let's check to make sure that this still runs. So I'm entering in 2. So it works nicely. But I can still go off the top. So let's fix that problem where we go off the top. How can we fix that problem? Well, this is how I want to do it. We prompt the user to select a column. Then we read it in. And then we compute it here. And, you know, if is a valid move, I could just use a function, but if that's a valid move, then we can move it. See, I'm thinking in functions now. It's just a task, checking to see whether a move is valid. It's just a task. We can put that task in a function. It's a simple task, but we don't need to complicate the code right here with the details of that simple task. But actually this won't do it because we need a loop, right? We have to prompt the user, we have to keep prompting the user until we get a good move. So actually, this needs to control a loop. So I'm just thinking, this is while not valid move C. Oh, you know what? I'm going to use a do loop. While that's our do. I don't use these very often. So do this code while that's not going to work either, is it? That won't work either. I'm going to go back to the loop. I'm going to do an infinite loop. Okay, this is the easiest for me. All right. All right, I'm going to go backwards. So if C is a valid move, then we move and we break. Otherwise, we stay in the loop and repeat. That's my loop. It took me a while to get there. I had to play around with it. So we have an infinite loop that we break from here. We only break if the move, if valid move returns true, and then we call the move function with that good C, and then we can break. This breaks from the loop. We could also have a return here too as well. That would give us the same thing. I'll just use a break. Now we have to implement valid move. I'm going to put it up here. That's a bool. There's the column. Now I want to return true if C comprises a valid move. So what do I do? It's a one-liner. How do I know we have a valid move? That's column 0, okay? Column 0. When is choosing 0 an invalid move? Well, it's when grid of 0, 0 doesn't have a dot. Now, you know, if this whole column is filled, that means the top cell is filled. If the top cell is filled, it means the top cell does not have a dot. So all we have to do is check to see if the top cell has a dot. If the top cell has a dot, it's a valid move. Otherwise, it's an invalid move. It's pretty simple, isn't it? So the top cell, so we have grid. The top cell looks like this. 0, that's our top, isn't it? And the column C. We want to compare that to dot. So if there's a dot in the Cth column of row 0, then it's valid. Otherwise, it's not valid. But you know, this is too wordy. It's so much simpler. Let's just do this. Let's just return the result of comparing the top cell with a dot. That does it. We're returning true if there's a dot where, you know, at the top of the column. Otherwise, we return false. So that's a very simple function. We could have put this condition. Look at that. We could have done this. Look at this. We could have done this. See that? Instead of saying if valid move C, move, right? We could do this instead. It's just a one-liner. That's valid move. But which code is easier to read? Well, this is you see how this is harder to read? It's missing that the words valid move. This is much easier to read. So even though it's a one-liner and we could get rid of a function, this is better documented code. This is code that's more readable. All right, now it's the same thing with the computer's move. The computer is taking invalid moves as well. We can do the same thing. We'll eventually pick, with the RAND function, we'll eventually get a good column. So actually, it's exactly the same code, isn't it? Oh, no, it's not exactly the same, because we have to pass in an O here. Once again, we sit in a loop that we break out of once we have gotten a valid column number. Now watch, I'm going to fill this up, okay? Now column 1 is filled, so if I pick column 1 again, what happens? Look at what the computer has. It's got O's everywhere. You know, in column 2, there's 2 O's. The other columns are just 1 O except for the last one. And you see it's just sitting in that loop now. It's not even printing the grid. There we go. Now we're moving along again. But you know, the computer actually has won the game right there. The computer has gotten 4 in a row, but we didn't stop playing, right? So we need to detect the win condition now. All right. So we print the grid, and then we do the player move. Maybe we'll do this. If X wins, I'll call it wins. If X wins, then we'll see out player wins. And we'll exit. Return 0. Main returns an int. We're going to return a 0. Or we can break. Let's just break. Maybe that's better. Just break. Break out of the loop. This doesn't break out of the if statement. It breaks out of the loop, the nearest loop, which is right here. So if the player wins, then we quit. We do the same thing for the computer. If O wins, then the computer wins. So now we have to do this win condition. So we have valid move, move. I guess we can put it here. So that's a Boolean value. The char is the symbol. Let's just do a stub. Whoever calls wins, whatever the first time we call wins, we just get a true. Let's check that. Just make sure we don't have any bugs in there. Player wins, that's what it looks like. It prints player wins, then we terminate. Oh, but you know what? I don't see my move. So I don't like that. I'd like to see the last move that wins the game. So after the player moves, we want to print the grid and then print player wins. The same thing with the computer. We got to make sure that we print the grid. Do you see that, how the stub helps? I'm solving a small logic error right now that we don't have to worry about when we do the more difficult task of implementing the wins function. So we're taking care of pieces of the problem a little bit at a time. Now that looks good. My move is displayed and it says player wins. That's great. Now let's go ahead and get this win function so it's not a stub anymore. So we need to check for 4 across, horizontally, vertically, and diagonally. Let's check for a horizontal win. So what we have to do there, it could be here, these four, right? Starting there, or it could be these four starting there, or these four starting there, or these four starting there, but no more. So we can start for row 0, actually for each row, we want to check the 4 adjacent cells starting at column 0, starting at column 1, column 2, and column 3. So for each row, we have to do 4 checks. We have to check the 4 adjacent cells starting at those start positions. But we don't need to check 4 adjacent cells starting at this position because there's only 3 cells in the grid. We can't go past the end of the grid. So this is the last column position that we need to check when we do that horizontal wind check. So we got to check all the rows. How many rows are there? 6. And we got to, for each row, we want to check those 4 positions. So it looks like this. If the grid in row R, position 0, equals symbol, and grid R0 or R1 equals symbol, we have to do this 4 times. So we could do that. We could have 4 of these. We could have 4 of these like this. Just change this number. So this is one way to do it. So that's if in this case it's a win, yeah, we say that symbol wins for that case right there. But or we could, because there's 4 things in there and they're identical except for this index. The index goes from 0 to 3, so we could just use a loop, right? So what about this? We want to stop at 3. We'll stop when we go past 3. So we stop when we hit 4. So now it's grid RC. And now what am I going to do? This isn't going to work. If grid RC, they all have to be equal to the symbol, right? Oh, now it's going to get complicated. How are we going to do it? But I'm not even going to think it out, right? Because it's already getting too complicated. I'm not going to waste my time. I already got a good expression here that works, and it's not that big. So why am I spending the time showing an alternative solution that's just getting more complicated? So I'm going to abandon that direction. And this line is too long to look at, so I'm going to break it up. You know, 4 is not too bad. I know the indentation isn't quite right there, but it's hard to read like that, isn't it? How about if I did this? There we go. Maybe that's better. So that checks the horizontal win. What about the vertical win? Now, as you watch me do this, this is not a problem you need to solve, right? I'm just showing you how to solve a problem. You have to solve the tic-tac-toe problem. So your code, you have to be thinking about it. Now, don't look up the solution. You're just cheating yourself. There's lots of solutions out there, and there's more than one way to do tic-tac-toe. But if you just look up the solution, where's your learning? There's no learning there. You need to think this through. I'm showing you how to think this a related problem through. So this is my recommendation. Now, of course, you're in charge of your own learning, so I may be wrong about what I'm suggesting to you, but this is what I feel. This is how I learn. I learn by, I look up a lot of stuff, okay? I look up a lot of things. I don't always solve problems from scratch. So, it's not practical to implement everything from scratch. But if you only look up solutions and you never try to solve a problem on your own, then you're not going to be in a very good position, because you'll eventually get to a point in your career where you'll need to know how to solve problems on your own. You won't be able to look it up, and you'll have to think it through. So this is a good exercise. And rather than wait till you're older and you can't solve a problem, it's good to learn how to solve these problems now while you're young. So let's check for the vertical win. So the vertical win means we start in this row, and we start in, say, column 0, and we look at rows 0, 1, 2, and 3. And then we stay in column 0, and we look at rows 1, 2, 3, and 4, and 3, 4, 2, 3, 4, 5. So there's 3 sort of sets of adjacent cells you want to check for each column. Yeah.
Didn't you fill up the columns from the bottom up?
Huh?
Didn't you fill up the columns from the bottom up?
It doesn't matter. You still have to check. It's possible that these 4 are all red, right? So it doesn't matter. We could start this way and then go this one and then go to that. We could go in a different sequence. Well, we have to check the same groups of 4 cells. Because remember, it's the computer plays and the user plays back and forth. So we don't know, what color disks are going to be dropped in these cells. We just have to have 4, and we're just looking for a vertical win. We're not looking for horizontal or diagonal wins now. All possible, we need to check all possible vertical wins in that column. So there's only 3 possible vertical wins in column 0. And for each column, for that matter, there's only 3 possible ways for one of the opponents to win through a vertical stacking in one column. So the outer loop is going to be column-based. See, so we're going to look at column 0. I want to check those 3 groupings. And we're going to go to column 1 and check for those 3 groupings. So the column is going to stay the same. We're restricted to column C. Did I do this right? I think I didn't do this one right. Ay, ay, ay. Did I get this one right? I didn't get this right. I can see already that I have a problem here. So we need two loops. You know, one loop is not good enough. So I got this code up here is not correct. The horizontal winds, and I just realized it down here. All right. So for each column, we start at row 0 and check this. And I can't explain it. I gotta just do it here. So for column 0, we're going to start at row 0, and we're going to check to see if the symbol is in this cell, the next cell down, the next cell down, and next cell down, starting from R. And then if all 4 of those are equal to symbol, we can return true. Otherwise, we continue with the loop. So now we start at R equals 1 instead of R equals 0. We do the same thing. It's the same issue up here for the horizontal wind. And forgive me for getting that wrong. So it's the same problem here. So the columns go to 7. But we only want to check 4 of them. All right, for the horizontal winds, we're going to iterate through the rows, okay? So we have a given row R. Whatever the row is, it's row R. And now inside this row R, we're going to start our check from column 0. We're going to check 4 cells starting at column 0. Then we want to check 4 cells starting from column 1. Then we want to check 4 cells starting from column 2, 4 cells starting from column 3. And starting from column 3 is the last place. That's column 3 right there. So we can check for 4 cells starting at column 3. We can't go to the next one because there's only 3 cells now. So this is where we stop. This is starting at column 1. Now this is the horizontal check. Column 1, column 0, column 1, column 2, column 3. That's it. So the columns have to start at 0 and stop when we hit 4. So it's C plus 0, C plus 1, C plus 3, like that. Now I'm happy with that. Okay, yeah.
Wouldn't the rows be also less than 4?
Wouldn't what?
The rows be also less than 4?
Would the rows also be
And that, but when you're checking for the vertical wind,
down here?
rows are would they also be less than 4?
No, because this is for the vertical wind, right? So stacked up and down. See, there's 7 columns and 6 rows. So if we start here in row 0, we can do 1, 2, 3, 4. See, and this is row 0, row 1. This is row 2. row 2, there's 4 disks that are, you see there's 4 slots. But if we go down to row 3, there's only 3 slots. So we run out of slots. So if you go down from row 3, we have this cell, this cell, this cell, and well, there's no cell down there. So we got to stop here. We're searching downward. We're searching downward. We're starting here, and we're examining the 4 cells that start here and go down. And so we can look at those 4 cells. Then we go to this one. And then we look at the 4 cells starting from this point going down. Are they all equal to symbol? If they are, return true. Otherwise, advance the row index down to the next row. Starting at this row position, look at the 4 cells going down. Are they all equal to symbol? If they are, return true. Otherwise, advance R, the R index, and it goes to there. Oh, R equal to 3 is no good because I don't have 4 cells underneath me. I only have 3 cells. So I have to stop there. We stop when R hits 3. Remember, this is R2, 1, 0. 0, 1, 2, 3. This is when R hits 3. We've gone too far. So when R hits 3, we've gone too far. Now that's because we've got 6 rows and 7 columns. That's why they're off by 1, see? And we could do the same thing for the diagonal check. Well, not the same. Now let's do the diagonal check later. Let's see if this code works. Let's see if this detects a win. The code will not check for a diagonal win right now. All right, so I'll do 3. What? What happened? Oh, so we got to return false. Look, see, we didn't return false here, right? We need to return false there. But the compiler, it's returning true. You know, I don't know why, but that's what it's doing. But the compiler didn't tell us, but if that's because we don't have any warnings on. If we turn on the warnings, uppercase WALL means all warnings. Show all warnings. It'll show us that we're not returning from a function. You see that? Warning. Control reaches end of non-void function. And it has the setting for it right there. But we turned on all warnings. This is just to turn on the return type warning. So we'll get the same error message with this. Control reaches end of non-void function. Line 86. Line 86 right there, see it? So hey, the control reaches the end of a non-void. That means you have to return something. We hit the end of the function, but we're returning, this function is non-void, so you need to return something. And we didn't have that warning on, so now we see that we have a bug there. That should be return a false, it's not a win. So I don't know how to turn this warning on. This is a good warning to have. I mean, definitely it's a good warning, right? Like maybe we should compile our code now with all warnings turned on. Well, now it looks good. We should probably do that. I need to change the course instructions to include that information actually. But I think some compilers will have by default more warnings turned on. It's just in this environment, all those warnings I believe are turned off. So this is a configuration file. We could probably go in there and do it. But I don't know what it is. All right, let's do this. Testing this. Vertical and horizontal win. Oh, I just got blocked. All right. And I'm going to test this. See, I'm picking the same column. It's not letting me do it. And let me drop in there. I'm trying to lose. I'm doing my best. And it is not smart, is it? The player wins. I was trying to lose, I actually won. So we got that horizontal win right there. Probably want to try to get a vertical win. We got it. Vertical win. Player wins. So we also want to make sure that the computer can win. What? I know what the problem is. Oh my God. It's like an infinite loop. All right, what are we going to do? I think if I kill this, it'll kill it. Oh no, no need to. The problem is this. I typed in a non-number. Let me show it to you again. If I type in like a T, okay, we'll get an infinite loop. See that? Now, that's because of that line right there. That I try to convert a T to an integer and it fails, so the input stream enters into an error state. And we're not detecting that. So I'm not going to get into that. I'm just not going to get into that. Maybe we will, maybe tomorrow we'll do that. All right, what about the diagonal move? Check for diagonal win. All right, so the diagonal win, look at it here. Well, we got to break it up into two phases. There's the downsloping diagonal win and the upsloping diagonal win. So downsloping would look like this. We start in the first row and we check these four going down, see? And then these four going down. And then these four going down. And then here in column 3, the fourth column, we can check these four going down diagonally. See that? But in the fifth column, column 4, we only have 3 cells on the diagonal, so we can't go. We have to stop. This is the last thing we need to do. We should stop when we hit this this column, column 4. So, and then we go down to this row, and we do the same thing. So each time we check a diagonal, we start at this row position, and the end of the diagonal is 4 rows below it, or 3 rows below it. So that means we've got to stop at this row here. This is row 2. Row 0, row 1, row 2. Row 2 has a diagonal here, see? But row 3 does not have this. It only has 3 cells in the diagonal, so we can't go to row 3. We're going to stop when we hit row 3. So that's right sloping. And then left upsloping is different. We can, we have to start here and look up like that, see? And so let's do that. Let's do the check for down sloping diagonal wind. Down sloping. So we're going to go, the rows are going to start at 0. And go to 3. And the columns are going to start at 0 and go to 4. Let me just check that again. The rows start here, so we're going to go down sloping. That's these 4. Then we go to the next column, do these 4, and so on till we get to this column, which is 0, 1, 2, 3. That's column 3 is good. The column 4, we only get 3 in the diagonal, so column 4 is out. So when C hits 4, we're done the loop. And so the diagonals look like this. You see that? So we start at RC, and then we go to R plus 1 and C plus 1. Then we go to R plus 2 and C plus 2. That's how we get the diagonals. What about upsloping? So with upsloping, we need to start, see this row only has three cells in the diagonal going up. So we have to start at this row. This is the earliest row that we can start checking upsloping diagonals. This gives us 4 cells in the diagonal that slopes up. So that is row 3. So rows 3, 4, and 5 are good. Rows 3, 4, and 5 are good. So once we hit row 6, we're out. Or not row 6. Yeah, row 6. Or index 6. And so when we do upsloping, we can go up to here. We go to the next column, and then we go up to here, and then we go to column 2, and we go up to here. That's good. Column 3, there's 4 cells in the diagonal starting at column 3. But at column 4, there's only 3 cells, so we run out of cells there. So this loop is okay, just the way it's written. The rows have to start at 3 and end at 5 and include 5. So upsloping means that that the row is, we have to use that calculation. So, you know, now we're upsloping, so we're going to go up a row. We're still going to the right with the columns, but we're going, the index for the rows are going down. Just to be consistent, I'll put the minus sign there. Now I can't think of any other, I can't think of any other cases that we need to look at. I believe the code that we have written gets all possible wind conditions. If you can think of a wind condition that doesn't get covered by that code, let me know. All right, let's check for diagonal winds. I made a wrong move. Oh well. It's a diagonal win, right? Right here. That one. Did I win diagonally? Oh no, it's a vertical win. So I didn't fully test this yet. Ah, yeah. So that should work right there, right? So if I go to 3, now I want to win on that diagonal. How can I do it? I got it. See the diagonal I got on there? So that's a diagonal win. It's upsloping. All right, so, but there's another situation we need to test for, and that's a tie. And if we fill up the whole grid and nobody wins, then we have to announce a tie. And that's pretty simple. After each move, we want to check for a tie. Well, after checking for a win, then we want to check for a tie. If there's a tie, and we don't care about the symbol, if there's a tie, we print the grid, and we're going to say tie. Same thing. After checking for the computer win, each time someone makes a move, we got to check to see if it was a tie. So that'll be, and that's going to be hard to check. And I don't want to do it because it's going to be too hard to do. We're running out of time. What else is there to do? That's it, isn't it? Is there anything else we need to do? Look at, do you see how the code grew? There's that problem of bad user input and how to recover from that. We can look at that next time if you like, or we could skip that. But I think we have a pretty nice solution here to the problem. And if you could have a solution like this to tic-tac-toe figured out, that would be great. So that's due on, what, a week from today, I think? Is that right? Whenever that due date is. Any questions? That's the end of our session, our development session. So we have one more meeting in the class, and we can review for the final or do whatever you like. Okay, so we'll see you